Okay, so a few months ago, we designed this project with EPANET software. As you can tell, this is a dead-end system. And water is coming from this storage tank. So this storage tank here is our source and supplies water to these 5 water taps. As you can tell, this is a fairly small project and it's a dead-end system, as I told you. Now, what we want to do today is to redesign this project, not with EPANET, but with WaterGEMS software. And this is exactly what we want to achieve today. Now, in case you are new here, my name is Engineer Lodrick, and if you haven't, please subscribe. And if you get value out of this video, forget not to like and also to share this video with your friends. Without further ado, let's start with what we planned to cover today. Okay, so this is the network in EPANET. Now, this is the same network in WaterGEMS software. Now, as you can see, we have our network in WaterGEMS already. Now, if you want to learn how to import your survey data in WaterGEMS, I have a very good tutorial which explains how to achieve that. So in case you're interested, link to that tutorial will be attached in the description below. Okay, so let's start with the settings. Okay, so let's start with the settings and make sure that we have the settings that we want for our projects. Now, to achieve that, let me go to Home, then select Option, and for Option, let me select Properties and make sure that I set the formulas and settings that I want for my project. Now, for friction loss formula or friction method, I want to use Hazen-Williams. So I'll select here Hazen-Williams, and again, for calculation types, I want to use hydraulics only. Is there anything here that I can change? Engine compatibility, I'll just use WaterGEMS 2.0. Okay, so I think I don't have anything more I want to change from here. Let me close this and let me go straight to Tools. And from Tools, let me select this and set units. Okay, so in units, what I am interested with or what I want to change is the units for flow. So make sure that, okay, so for my case, I want to use liters per second. Feel free to choose any flow units that you want for your project. And again, pressure, let me see if I have anything I can change. So for pressure, I don't want to use kilopascal. What I want to use is meters of water columns. Okay, so meters of water columns, this one. And again, yeah, I think that's it. If there is more settings, then I'll come back. For now, let me click OK. And let me close this. In case you want to change the view, you can just go at this point here and select CAD style. Okay, so for CAD style, this is the view that you have. But if I go again at this point and select the GIS style, then this is what I have. Okay, so if you want this, you can use. So for my case, I'm going to use the CAD style. Now from here, what I want to do is to assign demand on these endpoints here. To do that, what I want to do is to go straight to Home and select Demand Center. Now at the Demand Center, I want to use the Demand Control Center. Okay, so if I click the Demand Control Center, you can see we have this dialog or a pop-up window, and from here it's blank. At the moment this is blank, but what we can do is to select this drop down menu here and to select the Add Demands. Now, if I move this around this point here, you can see we have some, so we have this plus. So if you look at the mouse, you can see we have the plus sign. Now this allows us to select the nodes so as we can assign the demand. So from here, let me zoom and select this. So I want to select this one. And again, I want to select this. I want also to select this one and this one. And again, lastly, I want to select this one. If I click this sign here, you can see we have this window here. But for now, I don't want to set anything, but I'll just click OK. So before that, you can see the pattern here. We have the fixed. Okay, so remember this is a steady state analysis, so there is no need to change the pattern. Okay, but if you are using like extended period simulation, automatic here, you will need to change the demand pattern. So for now and for this tutorial, let me click fixed and click OK. You can see the demands here are 0, but what I want to do is to assign demand. So let me start with the J4, which is this one. So for J4, I want to assign 0.66. And again, for okay, so let me close this first and zoom a little bit. So this is J4. And again, this one here is J18. I want these ones to be visible. So for J11 and J25, I want to set 0.3. So if I go back here, so for J11 and J25, I want to set 0.3. So for J11, this one 0.3, 3, and for J25 again 0.33. So for this one here, which is J28, where is J28? Where is J28? So this one here is J28. So for J28, I want to assign 0.66. If I go back here and if I select Demand Control Center, so for J28, I want to select 0.66. And again, for J18, I want to set here 1.02. I think we can close this dialog. Okay, so far what we managed to achieve is to assign the demand to the respective nodes. Okay, so what we want to do from here is to run this model and see if we have any error. Then we can take it from there. Now the next step, as I told you, is to run this model. And before I run, let me go straight to this point here and select validate. As you can see, for now we don't have any issue. So if I compute, you can see this is what we have. So after running our model, you can tell we don't have any error. But is everything okay? No, of course it's tempting to say everything is okay, but it is not. Now what we want to do is to cross-check each and every parameter to make sure that at least we have the parameters that we have or that we need for our model. So parameters like velocity, like flow, like pressure, and everything in between. So just to make sure that we have the model that is well optimized. So let's proceed and see what we have. Now to achieve that, what we need to do is to use the annotation function. Of course, this is the WaterGEMS function. And let me go straight to this. Let me start with pipes and let me go straight to pipes and select annotations. Okay, so for annotation, what I need to do is to display. Okay, so on each pipe, I want to display velocity. Let me start with velocity. So on each pipe, I want to display velocity. So let me go straight to results and select velocity. Where is velocity? Here it is. Okay, so if I click apply, you can see we have the figure here, but these figures here are not visible. Okay, are not visible. Now what we can do, let me click OK and let me disable labels. Okay, let me disable labels. And if I select again this and I select editing, so on velocity, if I select edit and I go back around this region, if I offset, because at the moment you can see this one here lies on top of the pipe, but we don't want this. Let me use the offset function to make sure that these values, velocity values, are displayed on top or even below the pipe. So from here on X direction, I want to offset these velocity values in X direction with, let's say 1. If I click apply, you can, so the X value does not work. If I select Y, select 1, you can see for now the values are pushed upward. And if I select 2, you can see now this is the values that we have. Okay, so this is the velocity values that we have. If I click apply, then let me click OK. So far we have achieved to display velocity values on each pipe by using annotation function in WaterGEMS. But as you can tell, the velocity values, if I take a look here, they are quite small. Okay, so they are quite small, and this is not what we want. Of course, it depends on which design manual that you are using in your country, but what I want to achieve is at least 0.4 all the way maybe to 1.2, 1.5 meters per second. And to achieve that, what I need to do is to play with the pipe diameter, internal pipe diameter, up until I have the required velocity values. So let's proceed and see what we have. As I told you, we want to make sure that we increase these velocity values, and to achieve that, we have two options. We can just double click just to what we are doing in EPANET, or what we used to do in EPANET. You can just double click one pipe after another to change pipe diameter, but that is counterproductive. What I want to do is to use Flex Table to make sure that I change the pipe diameter on each pipe. Okay, so if I go to Home and I select Flex Table and I select pipes, you can see these are the pipes that we have for our model. Now, what I need to do is to start with the first pipe. So this is the first pipe, and if I am not mistaken, it is this one. Okay, so it is this one. So this one here is the first pipe. For now, the velocity value here is 0.16. What I need to do is to increase or rather to reduce the pipe diameter, at least to make sure that I have the velocity that I want. So from here, from 152.4 millimeters pipe diameter, I want to take this all the way to, let's say, 90. Remember, you are supposed to use pipe internal diameter and not the outside diameter. So if I run at this particular moment, you can see for now we have here 0.47, which is not bad for my case. If I go again, if I select the next pipe, which is this one, yeah, so these two pipes, let me use not 3-inch, but rather 2.5, 2.5-inch pipe. 2.5-inch pipe. Remember, this is HDP pipe for my case that I am using. So for this pipe, the internal diameter for my case is 69. So if I apply here 69 and also this one here 69, and if I run again this model, what do I have? You can see for now we have 0.6, which is not bad. And again, let me do for the rest of this branch here. So I want to use 1-inch pipe. So for this, I want to use 1-inch pipe, just 1-inch pipe. So the internal diameter for 1-inch pipe is 28. And again here 28, 28, no, 28. And again here 28, and here 28, lastly 28. If I run this model again and see which velocity values do we have now. So 0.5, which is not bad, because provided that we had a flow of 0.33 liters per second, which is not bad for our case. Now again, I want to shift to this branch. Okay, so from here to here. So this branch, so I want to apply the same 2.5-inch pipe, and the internal diameter for 2.5-inch pipe is 69 for my case, 69. So 69, and here 69, 69, 69, and again here 69. Okay, so let me go back here. The internal diameter for 3-inch pipe is around 85, if I'm not mistaken. Okay, if I run this model, let me see which velocity value do we have. Do we still have 0.1? So at the moment we have 0.1 meters per second. So if I run this this model, you can see for now we have 0.54, which is good. And again, if I move to this small pipe here, where is it located? If I select this, okay, so this one. Now for this one, you can see for now we have 0.06. Okay, 0.06, and the flow around this point, the flow was 1.02 liters per second, if I'm not mistaken. Okay, so what I need to do, let me use again the same pipe 69 and see what I have. No, 69 is quite big. Let me go with 45. No, 44, which is 1.5 inch pipe. If I run this model, you can tell for now we have a 0.67. And again, let me go back to this branch here. So this branch, but this one here is not visible. I need to deactivate the label for each junction. Let me go to junction and deactivate the label. So let me deactivate. Okay, so now what I need to do is to change the pipe diameter at this portion here. Okay, so for now we have 0.05 meter per second. This is quite small. Again, we want to do the same thing. So let me go to flex table and track this branch. Where is it located? So this branch is this one. Okay, so yeah, around this point. So at this point, I want to use, let's say, again, 2.5 inch pipe, 69 internal diameter. Again here 69, and again here 69. Okay, if I run this model again, let me see if I still have 0.5. If I run this model, you can tell for now we have 0.26. Again, this is too small again. Let me go back and reduce the pipe diameter. So from 2.5 inch all the way to 1.5 inch pipe. For 1.5 inch is 44 internal diameter. 44. Yeah. So let me run this model again. You can see for now we have 0.65, which is okay. And again, I need to shift back to these two pipes. Yeah, I think for now we have a good figure. Okay. Except this one. I think we're still having some issues on this pipe. Now, instead of using a flex table, let me go and put its value manually. So the internal diameter here, because on the other pipes like this ones and this ones, what did we have? We used the 1.25 inches pipe. And again, if I double click this, I want to use the same 44. If I run again, you can see for now we have a good value. So 0.65 meters per second, 0.65 meters per second. Now we have the last branch, which is this one. So I need to take care of this branch here. As you can see for now, we have 0.04 meters per second, which again is quite small. Let me go back to flex table and see what I have. If I select pipe again, let me go back and select. So for these ones, from this area here, because these are the only pipes that I have not touched. So from here, let me put 35, which is 1.25 inch pipe. So this one 35, and again here 35. So if I run this model again, what do we have? Okay, so for now we have these values, which, so before we had, so on this branch we had 0.04, but for now we have 0.69 meters per second. So as far as velocity goes, I think we are doing okay. Okay, so that is velocity. But when we design a water network system, we are not only concentrating on velocity. We have some other properties as well. For example, we can even check flow. We can even check pressure. And again, we can check the unit head loss. On each pipe, we can check unit head loss to see if we have the values that are sufficient for our network. Now, let's go and have a look at pressure. So this is my network. Let me go straight to junctions and see what I have. So this one here is junction. If I go to annotation and I select pressure, If I go around this area and I select pressure, so for results, if I select pressure, so this is the pressure. If I select this one, and if I click apply, you can see on each junction we have some values here. But let me click OK first. Let me click apply, then click OK. I want to disable the velocity values. You can see for now we have the velocity, the pressure values on each junction, but it's not looking okay. So what I need to do is to go back to select this and click edit, and let me take this one around this area. So I want to move these values in Y direction. So in Y direction, so I want to move them down. So in Y direction, let me put them in, let me shift them with -1 in Y direction. If I click apply, you can see it moved a little bit. Let me put here again -2. And if I click OK, at least we are having some figures here. Let me take it back to -3. Okay, but this is not that enough. Okay, so, and again, let me shift it to, in Y direction, let me shift it to -1. Okay, if I apply -1, not that bad. So let me click OK. So that is pressure. But if you noticed, we have some issues here. If I view this network, you can see we have some junction with very low pressure, like 2 meters of water columns. Remember, this is a residual pressure, and for my case, this is very small. At least we need to have like 5, maybe 6 meters of water columns minimum. Now, what we need to do, we have two approaches, either to increase the pipe diameter or to change the storage tank. Remember, our source here is a storage tank. Now, we can play with the storage tank to see if we can increase this residual pressure, especially at the end point. Okay, so at the end point. Because as of now, the storage tank that we are using here is the ground storage tank. We can propose, maybe we have like a riser tank. Okay, so a riser tank, maybe 6 meters riser tank, or 8 meters, or even 9 meters. Okay, so we'll see which configuration will yield a good pressure values at the end points. So let me go and change the pipe configuration. So from the ground storage tank all the way to riser tank. Let me start with 6 meters and see how residual pressure will respond, especially at the water taps or the end points. Let me select this storage tank here. If I double click this storage tank, we have some properties here. But the property or properties that I am interested with, the first one here is elevation. As you can tell, this is the elevation at the ground. Okay, this is the elevation at the ground. And if you can look, as of now, we have 1389. If I'm not mistaken, 1389. Now we want to take this value, 1389, and plus it with 6 meters. Okay, so we want to use the riser tank with 6 meters height. So the result that we are going to get after summation, this will be our new elevation. Let me do that and see what we have. So from 1389, if I add 6, what I'm going to get here is 1395. 95. If I close this, okay, if I close this, now what we'll be interested with is the pressure at these end points, okay, at these end points. So as you can see, for now we have here 2 meters, and again here 2 meters. Let's see, after adding this 6 meters, so the riser tank height of 6 meters, and see what we have. So if I click run, and if I close, you can see we don't have any changes. Let me go back to this storage tank. This is our elevation. Let me go back and select. Okay, so from here, let me select this 1385, and the minimum water level. Okay, so let me select this 1385. If I close this and if I run this mode again, it seems as though we have some errors, and of course the error originates from the storage tank. If I close this and go back to the storage tank, if I select, you can see, okay, so we need to change the initial water level. all the way to, so 1395 plus 2 is 1397. 97. And again, the maximum level is 1397. If I close this, and if I run this model, you can see for now we don't have any error. Okay, so for now we have here 6 meters. And again, at this point here, 7 meters, not 6. And again, at this point, we have 10. We have again 11. And also we also have here 12 meters of water columns. So for my case, I feel this is sufficient, but we have some issues around this junction. I think we have some issues here. If I double click this, it seems as though the elevation value here is not assigned. Let me go back to EPANET and select this one here. The elevation was how much? 1390. If I close this, 1390. And if I close this and if I run again, yeah, so for now everything is okay. Okay, so far we managed to work with pressure, and also we managed to work with velocity. So as far as our model goes, at least for now, those two properties, velocity and pressure, we don't have any other issue. Of course, we had some issues with pressure with the minimum of 2 meters. As I said, that value is quite small. What we did, we changed the storage tank configuration, because our source here is the storage tank. So we changed the storage tank configuration from the ground storage tank all the way to the riser, at least to make sure that we achieve the required minimum pressure on each node, especially the end nodes. Now let's see if we have some other properties that we can play with. Okay, so let's start with the unit head loss on each pipe and see what we have. So let me go back to pipes. If I deactivate this and if I select pipes, so for pipes, I need to select, so for annotation, I need to go to annotation, then on the results, if I select head loss gradient, so head loss gradient, if I select this head loss gradient, if I run this model, you can see the unit value that we are having here is meters per meter. Again, this is not units that I want to use for my case. I want to use meters per kilometers. Again, you can even use tools. You can go back to this point here to change the units. But for my case, at this point, I don't want to use the tools. I want to double click this. And if I go down around this area, you can see we have the head loss gradient. So from this, I want to select this one. So if I right click this, I right click around this area and I select units and formats. You can see we have here the unit. So instead of meters per meter, I want to use meters per kilometers. Okay, meters per kilometers, and display precision, let's say 2. You can even use 1. For my case, let me use 2. Okay, so this is the units that we have, but the display is not as good. So let me go back here and select. So let me go back to pressure, to pipe, and select head loss gradient. If I select this and I select edit, you can see this is the annotation for head loss gradient. Now, what I want to do is to shift this downward. You can even take it upward or downward, because I want it to be visible instead of now it's not that visible. So let me take it in Y direction, -2 in Y direction. If I apply, you can see for now what we are having. This is the values that we are having. The minimum head loss gradient is 3.9 and the maximum is 15. Not that bad, because my velocity here is quite appealing. I don't see if I activate the head loss gradient and the velocity at the same time, you can see the velocity values, they are good. So I can even choose to maintain the same values. Again, feel free to play with the values. Maybe you can have the even better results compared to me. But if I think I have some issue here, around this point here, I have some issue. You can see the head loss gradient here is 165 and the velocity around this pipe here is quite big. And I cannot leave this the way it is, what I need to do is to double click this pipe. And of course you can even use a flex table, but I want, because it's just a single pipe, I can just double click it and see what I have. So what is the pipe diameter? The pipe diameter here is 1.25 inch pipe, which is maybe for this case is quite small. If I double click this one, how much did we have? 65. So I need to change the diameter here to 65, which is 2.5 inch pipe. So if I run this, you can see for now we have this value, which is not bad. But let me see, we have here 65, but why HDP? Okay, so not bad. That is the values that we have for our model. Okay, so that is our network. As you can tell, we managed to play with velocity, we managed to play with the height loss gradient, and again, on each junction, we managed to play with a pressure. At least for now, we have sufficient pressure for our network. Now, feel free to play with the values. Maybe you can come up with something better compared to what I managed to achieve right now. As I told you, if you're new here, feel free to subscribe and feel free to share this video with your friends. And until next time, have a good day.